Hello students, welcome to my channel Positron. As you know that positron is an antiparticle of electron. You know within the atom the fundamental particles are electron, proton and neutron. So positron is actually the antiparticle of electron. Dear students, today's topic is precision, accuracy and error. Question is that why do we study error analysis? What is need of studying error analysis? Dear students, answer is very simple. If 10 people, 10 very expert people are carrying the same experiment at the same place, even then they will not get the same result despite they are the experts. The result would not be same because they are experts, so you cannot say that they are wrong, they have got the wrong answer. So it means let you know the value of acceleration due to gravity at a place might be, let at your place the value of acceleration due to gravity g is 9.81 meter per second square. If 10 people are carrying on the experiment, then nobody will get actually 9.81 meter per second square. Somebody will get 9.812, somebody will get 9.79, somebody will get 9.65, like so on. Because they are experts, so you cannot say that their answer is wrong. So it means, what I mean to say that some error in every experiment should be permissible. So to get, and if you say that you have to get the exact answer, then nobody will get the exact answer. So that is why some error is bound to come because of many reasons we will discuss further. Then you cannot say that every answer is wrong. They are close to the experimental value of that experiment. Let the value of G is 9.81, so somebody will get 9.812, somebody will get 9.79, somebody will get 9.72. But you cannot say that somebody has got G is equal to 7.85, then it is a wrong answer. So means closer to experiment value you have to come, then you are right. So in every experiment there is a high possibility of coming the error, and that is why, and up to some extent that error should be permissible. So error is that we are studying the permissible error in a possible error, in an experiment, the possible permissible error. Dear student, three things we have to discuss here: precision, accuracy and error. Now, very first, what is the accuracy? Just I have given you the example of that. Let at your place the value of the small g is at 9.81 meter per second square. This is just I have supposed you know that the value of these keep changing and keep changes if you move from equator to the pole, okay, and even changes if you go above the surface of the earth or below the surface of the earth. So at your place G is 9.81 meter per second square. Now what is the precision we are going to discuss? Somebody has got this value 9. The first observer has got the value 9.79 meter per second square, and the second observer has got the value that is 6.923 meter per second square. What I have said, you know the value of G is close to the 9.8 meter per second square. Let at your place where you are sitting and watching my video, that the value of G is 9.1 meter per second square at your place. The two people were carrying the experiment and trying to find out the value of G. One has got 9.79 meter per second square, and second person has got E2, that is 6.923 meter per second square. It's clear that this value is more closer to experimental or true value of that experiment. So, if you think that accuracy, then it is more accurate than this because it is far away from the experimental value, but it is closer to the experimental value. That is why this one is a more accurate than this. But what is now I'm trying to let you understand that what is the precision. I am trying to bring you familiar with these words. Precision is what this value has we have obtained, that first person has obtained this value up to the 2 point of decimal, yet it is very close to the experimental value, and the second person has got the value up to the 3 point of decimal, yet it is far away from the experimental value. Then dear students, in the terms of precision, this is a better value than that because the first person has got the value, he has observed, he has find out the value of experiment up to the 2 point of decimal, but the second person has got the same value, has got the value in the same experiment up to the 3 point of decimal. So that is why E2 is a better in precision than E1 because it has been find out up to the 3 point of decimal, but E1 has been find out up to the 2 point of decimal. Now dear students, we are going to discuss the error again. Just I have told you all. Dear students, just I have told you that if many of the expert people are carrying the same experiment, then they will not get the right. They will not get the exact answer, the same answers. If they have not got the same answer, then you cannot say because they are expert, you cannot say that every answer, everyone is wrong. So, what I mean to say, because of many reasons, you cannot get the true experimental value of an experiment at any time. So, if you cannot get the true experimental value of an experiment, then up to some limit, there should be a permissible error. The value of capital G is a universal gravitational constant. Is it 6.63 to 10 raised to the power minus 11? Unit I am not discussing right now. It's in MKS. 6.63 to 10 raised to the power minus 11. If you are unit is a Newton into meter square per kg square. The value of this 6.63 to 10 to the power minus 11. Dear students, if 2, 3, 4, 5 people are given the experiment or the challenge to find out the value of capital G, nobody will get this true value. Actually, their value might be 6.61 into 10 power minus 11, 6.60 into 10 power minus 11, 6.62. But it's a rare that if you get the same value, means you are fortunate enough, and that is not possible actually in physics. So, dear students, our objective is why do we study error analysis? That our objective is to find out the value closer to the experiment value. How we take all possible precautions while carrying on the experiment, and we try to reach to the true value. Okay. So error is, despite taking all the precautions, we are not able to find out the exact or true value of an experiment. Now, the question is that why do this error arises? What are the grassroots reasons behind these errors? The error can be divided into two types. Dear students, error can be divided into two types. One is a systematic error, and another is a random error. Dear students, at a glance you can differentiate between the two. Systematic error means error about which you know. You can avoid these error by taking many of the precautions. You can avoid these error. And random error, a error you do not know. Despite taking all of the precautions, you will not get the exact experimental value. Even then, you are just close to the experimental value, but you will not get the experimental true value. Now, systematic error, how many types of systematic error possible? Number one is instrumental error. Instrumental error means the error in the instrument might can cause the error due to measurement. Like the weight, you are weighing some object, some material, and you are using a weight of 100 gram, and that 100 gram is might be 99 gram, or might be actually it is a 101 gram, but it is denoted by 100 gram. So your answer would not be right. You know that our weights and measurements are taken from NPL. NPL is a National Physical Laboratory, New Delhi. The weights and distances, that is the prototype I am discussing about. The prototype of weights and measurements, the meter sticks, the prototype of meter stick and weights are released from NPL New Delhi, National Physical Laboratory, New Delhi, and distributed throughout the country. Okay? If the company which is making the weights or meter sticks, they have what I have given you the answer. Let a weight of 99 gram, but they have unfortunately they have denoted it with 100 gram. Then actually that is a 99 gram, but you will note it 100 gram, so your answer would not be right. So it is an instrumental error with the instrument, or normally the thermometers you are using at your home to find out the fever in Fahrenheit or temperature of your body, that might not be calibrated good. If it is not calibrated absolutely, then it will not give the right answer. So the fault of the instrument, the error in the instrument causes the error in your experimental value, and that is called the instrumental error. Dear student, second is called imperfection in technique. Imperfection in technique. Imperfection in technique, dear students, means the instrument you are using, you do not know that how it is used. The correct way of using, you do not know. Imperfection means like you are trying to measure the fever of a person, and except of rather to put below the tongue, you have put in on the armpit. Then it will not give you the right answer, right temperature. So to get the right temperature of human body, that you know the normal temperature of human body is 98.6 degree Fahrenheit. The temperature of normal temperature of human body is that is 98.6 degree Fahrenheit. But if you are normal and if you keep the thermometer below your tongue, then you will get the right answer. If you will put here in the armpit or rather any place, then you will not get that answer. So it is an imperfection technique. The particular ways of using an experiment, using an instrument, if you are not following that way, then your answer will not be right. And third one is personal error. Personal error. Dear student, error caused due to person who is carrying on the experiment is called personal error. What I said, the error caused in an experiment due to a person who is carrying on the experiment is called personal error. Dear student, it is said that if you are carrying the experiment of physics, you should be calm, quiet, and you have to keep the patience because it may take 2, 3, 4 hours, and despite repeating number of the time same experiment, same procedures, you have not got the right answer. So need to keep the patience, be calm, be quiet, only then you can carry on the experiment. So personal error is like you are just measuring the length, you are measuring small length like 2.1 millimeter or 2.2 millimeter, then your head should just below, just above the scale. If it is just either left or right, then you rather to measure 2.1 millimeter, you will read 2.2 millimeter or 2 millimeter. So there might be a change of 1 millimeter. This is called parallax. The exact method is that your head should be just above the scale. If it is either left or right, then you will not get the right answer. And this error, it is called a parallax. Like if you are a bit right, then rather to read 2.1 millimeter, you might read 2.2 millimeter. If you are just a left, you might read this 2 millimeter, 2.0 millimeter, 2.0 centimeter, millimeter. I mean, because of parallax is what? That your head is just not above the scale, just not above the reading point, but it is just either left or right. Then there will be a variation of a millimeter, and that variation is called parallax. And dear student, that error is called to be the personal error. These are the errors you can avoid. Instrumental error, take a proper instrument, really absolutely calibrated instrument, okay? Imperfection in technique, improve your technique, okay? The best way, the procedure given, follow the procedure given, then you can avoid these two errors. Personal error, be calm, be quiet, repeat that experiment number of times, then you can avoid these errors. Despite avoiding these errors, you cannot get the true value. Like just I said, the value of acceleration universal gravitational constant is 6.6 into 10 raised to power minus 11. You cannot get that exact answer despite avoiding all the errors. And that is that why you are not getting? You do not know that. What wrong are you doing? Some unexpected thing is happening, and that unexpected thing is called to be the random error. The error about which you do not know is said to be the random error. Now, dear students, I am moving ahead. One is a dear student, one is a least count error. Least count error. Least count error is what? Dear student, let measurement, you are just measuring a small distance. A small distance, I mean, the three scales I am taking into consideration. First is a meter scale. Second is a vernier scale. Meter scale, least count is what? Least count is a, and third consider another one, that is screw gauge. The three instruments we have considered to measure a same distance, same units, same measurement, same distance. All these instruments measure the distance. Here, three instruments I have considered. One is a meter scale, second one is a vernier scale, and third one is a screw gauge. Least count is, let's start first about the least count. The minimum exact measurable distance from an instrument is called least count. The minimum exact measurable distance from an instrument is called least count. The three instruments I have considered dear students. One is a meter scale, another is a vernier scale, and third one is screw gauge. Meter scale has the minimum what distance you can measure. That is a 1 millimeter. That in centimeter you can say it is a 0.1 centimeter is the least count. Means the minimum measurable distance using the meter scale is a 0.1 centimeter or 1 millimeter. It is 0.1 centimeter, dear students. Vernier scale, you can measure 0.01 centimeter, the exact distance from this scale. And third one is a screw gauge. The least count of screw gauge is 0.001 centimeter. Dear students, the three instruments I have considered: meter scale, vernier scale, and screw gauge. What is the least count? I have said to you, the minimum exact measurable distance from a minimum exact measurement from an instrument is said to be the least count. So, meter scale has the least count 0.1 centimeter, vernier scale has the least count 0.01 centimeter, the screw gauge has 0.001 centimeter. Means meter scale can measure minimum 1 millimeter or minimum 0.1 centimeter. With the vernier scale, the minimum exact measurable distance is a 0.01 centimeter, whereas with the screw gauge, the minimum exact measurable distance is a 0.001 centimeter. Now, dear students, let us talk about the least count error. Let us, using the meter scale, the same measurement comes out to be 1.1 centimeter. A measurement you have find out using the meter scale, because it is a least count is a 0.1 centimeter, means after the decimal you will get the answer up to the 1 point of decimal. You have got 1.1 centimeter, so least count error, even or percent least count error, even that becomes the least count divided by the value you have find out into 100. So it is, dear students, 11,999.110 9.09%. The error comes out to be 9.09%. Now the same measurement is done using vernier scale, and you have got the value 1.12. This time you have got 1.12 centimeter, because the least count is a 0.01 centimeter using vernier scale. So you will get the answer up to the 2 point of the decimal, and your answer is a 1.12 centimeter. So E2, this time least count error will be 1.01, the least count of that instrument divided by 1.12, the measured value, into 100. Dear students, it is actually 100 over 112, and if you solve, that answer will be nearly 0.9%. In the past, when you were using meter scale, you have got the error up to the 9% approximately, and when you are using the vernier scale, you have got the error up to the 0.9%. And now let's measure the same distance using the screw gauge. This time error will be E3 equal to, dear students, it will be 0.001 upon 1. Let this time we have got, while using the screw gauge, you have got the same answer 1.124 centimeter. This time your answer is a 1.124 centimeter. So error will be least count divided by measured value into 100, and this is actually, it is 1 upon 1124 or 100 upon this, and this value will be 0.09%. Dear students, the same measurement when you have done using the meter scale, which is having the least count 0.1 centimeter, there was 9%, approximately 9% error given. But when we use a better instrument of least count having up to the 2 point of decimal, that is 0.01 centimeter, the error becomes 0.9%. Just 1 by 10 becomes. It means as the least count has come from 2 point from 1 point after the decimal, the error became 1 by 10. Now you have used more better instrument to measure the same distance, and this time it is a screw gauge, and whose least count, which has the least count 0.001 centimeter, and this time you have got the error that is 0.09%, 10% of even that. The minimum error is in which, that is, means if you use an experiment which has a lower or least count, minimum least count, then it will get more and more better results. I hope, dear students, my videos are going to be beneficial to you. Okay, I will be regularly making my videos, and just soon you will get my next video. So I hope if you think that it's going to be beneficial to you, then please like, share, comment and subscribe to my videos. Thank you.